Today will be much easier than yesterday, I promise. But you may want your calculator handy. So make sure you have that out. Quadratic formula used for solving quadratics in standard form. It's the most common method for solving quadratics. So we'll go back and forth between that and factoring for most of the stuff. The biggest thing with quadratic formula, I'm not going to require you to memorize it. I'll give it to you, but you got to know how to use it. And most importantly, your quadratic has to be in standard form. The most common mistake is that your equation's not set equal to 0. If it's not set equal to 0, you can't use it. So you have to get your equation in standard form first. Then you can start evaluating using the quadratic formula. And from there, it's just plug and chug. The leading coefficient, that's your A value. The coefficient of the linear term is your B value. And the constant is your C term. Okay, so those values will just plug straight into the equation, negative b plus and minus square root of b squared minus 4ac all over 2a. So let's get into it. Looking at our quadratic, what is the value of a? What's the value of b? What's the value of c? Good. From there, it's just plug and chug. So I want to see you put it into the formula. That's first and foremost, because we're all mistakes, or we're all humans and we make mistakes. Not all mistakes, we're all loved. We're all human. We all make mistakes. Arithmetic errors happen. They're very common. So you need to make sure you put it in the formula, so at the very least, I know that you know where everything should go. All right? So we have negative b, negative b plus or minus the square root of b squared minus 4a and c all over 2a. That's step 1. Step 2, I want you to simplify it in chunks. Don't try and evaluate it all at once. You're going to make a mistake. All right? So we can simplify the double negative. We can simplify the denominator. And then we can simplify what's in the square root. Now, most common mistake that I'll see is this. That's the wrong answer. Why? Where did I mess up? But where did I mess up putting that into the calculator? What do I need to do different?
Parentheses.
Where? Around the negative 11. If you don't put a parentheses around that negative 11, what it's doing is it's giving you 121 and then making it negative instead of just giving you 121. So you need to make sure that you're putting it into your calculator correctly. Those parentheses make a big difference. So then we get our 169. That's step 2. Step 3, we can kind of simplify. And how we simplify will vary based on what we have inside the radical. We can take the square root, and evaluate it all the way. Can I square root 169? Get 13. So we have 11 plus and minus 13 over 8. So now we have 2 problems to solve. 11 plus 13 over 8 and 11 minus 13 over 8. What's 11 plus 13? Divided by 8. 11 minus 13. Divided by 8. So my 2 solutions are 3 and negative 1/4.
Can you zoom out?
The solution of the scenarios.
That matter. Skim it. All right. What's my value of A?
2.
What's the value of B?
-14.
Why is it -14?
Because you add it to the other side.
Yeah. Let's get it in standard form first. And then you can identify A, B, and C. C as being, what's C? 19. All right, go ahead, solve it. Plug and chug. Go, go, go. What do we get inside the radical? 44. Okay. Can I square root 44? Can I simplify it? What does it simplify to? Yep. 14 plus or minus 2 root 11. So we're not going to have rational solutions. We're going to have irrational ones. Okay. But we want to simplify the radical and then see if we can simplify the fraction. If all three factors have a common, or sorry, if all three terms have a common factor, then we can simplify it. What can I simplify it by? Divide everything by 2, and we get 7 plus or minus root 11 over 2. All three of those factors, or all three of those terms have to have a common factor though. If I didn't have that 2 in front of the root 11, I wouldn't be able to simplify that fraction at all. From the assignment yesterday, did you guys see does MATLAB let you put plus minus? Yeah? Okay, that's what I thought. Alright.
Wait, so that's the answer, right?
Yeah, that was the answer. We couldn't simplify it anymore. Alright, what's A? It's not in standard form, so let's distribute it out. We get x squared plus x plus 5x plus 5 equals 10x. So what's standard form going to be? So what do we end up with? Excuse me. Minus 4x. So what's A? What's B? C? Alright, plug and chug, go for it.
Is there like a shortcut for the quadratic? I don't remember what it was, but I think it was if they were like even or something like that.
What do we get inside the radical? What's the square root of negative 4? 2i. Can I simplify this fraction?
Yes.
By what?
2.
4, 2, and 2, all divided by 2, leaves us with 2 plus and minus I. Alright, so that's quadratic formula. Last thing I'm going to talk about is the discriminant. Discriminant is actually part of the quadratic formula. So I'm going to give you the quadratic formula. I'm not going to give you the discriminant because it's part of the quadratic formula. You just need to remember it's the part under the radical. B squared minus 4ac. The discriminant allows us to make a prediction on the number and type of solutions. It also tells us ahead of time whether or not our polynomial is factorable or prime based on these solutions. So we can get 4 types of numbers underneath the radical. I can get a positive number that is a perfect square. Like our first example, what do we have under the radical? In the very first problem we did today. What was underneath our radical? The very first thing underneath the radical. Under the radical. 169, okay? A positive number that I can square root. When we have a positive number that we can square root, our answer will end up being 2 rational numbers. If we have a positive number that we can't square root, we end up with 2 irrational solutions. If we have a negative number, we get 2 imaginary solutions. The only one we didn't have today is if our discriminant was 0. We have a 0 underneath the radical, okay? That gives us 1 rational solution. And so think about this. If you have positive and negative square root of 0, what's the square root of 0? 0, right? If you add or subtract 0, does that make any difference? No, 1 solution. So a positive perfect square will give us 2 rational. A positive non-perfect square gives us 2 irrational. A negative root gives us 2 non-real complex solutions. And then a 0 discriminant gives us a rational solution. Also, if we have a rational solution, if we have rational solutions, that means that those quadratics were factorable. Okay? They were factorable if we have a rational solution. If we don't, then we have to use the quadratic formula. Those polynomials will be prime. Okay? If we do not have rational solutions, that means the polynomial is prime. So we're going to use the discriminant to predict the number and type of solutions for each equation. You don't need to solve. You don't need to solve. You don't need to tell me what the answer is. I don't want to see you tell me what the answer is. I don't care what the answer is. I just care about the discriminant. The only thing you need to do is evaluate b squared minus 4ac. That's it. It's the only math you have to do. If you're doing anything more than that, you are wasting your time. We just need to evaluate that part and then use the answer we get from here to determine which of these we have. And then based off of that, determine whether or not we can factor it or whether we have to use quadratic formula if we want it to solve. So, what's my value for b on this quadratic? What's my value for a?
10.
What's my value for c? If I evaluate that, what do I get? What is negative 1 squared minus 4 times negative 2? 81. So, the discriminant equals 81.
2 rational solutions.
2 rational solutions. It's positive and the square of an integer, so it's 2 rational solutions. 2 rational solutions. Now, because it's rational, does that mean I can factor it or I have to use the quadratic formula? If it's a rational solutions, that means it's factorable. Factorable. Alright? Go ahead and do B and C on your own. Remember to put those in standard form first before you evaluate your discriminant. What's the discriminant for B? So, how many solutions of what type? 2 irrational. 2 irrational. And since I have 2 irrational, can I factor it, or do I have to use quadratic formula?
Quadratic.
Gotta use quadratic. So, prime polynomial. What about C? What's the discriminant for C?
Minus y squared.
It's 0. So how many solutions do we get?
1 rational.
1 rational. 1 rational. Can I factor it, or do I have to use quadratic formula? We can factor it. And fun fact, if we have a discriminant of 0, it's actually a perfect square trinomial. So now my thing. Perfect square trinomial. And that's it. Questions, comments, concerns, queries, or conundrums? Cool. All right. You